initially I just wanted to say this is a pretty basic AI that I've thrown together pretty quickly, so there's definitely some bugs to fix and there's improvements to be made. That being said, at the moment the AI can't predict if its next move will give you the win on the next round, so I'll be improving that obviously when Dreams comes out fully, but yeah, I don't really have time for that before the beta finishes. So this is in-game playing against the AI at 3 times the speed. It's not too slow to figure things out, but this is just to sort of show you what it'll do in an actual game. I'll just let this one finish off and you'll see I do miss a row of 3 there, and it doesn't actually block it, but I'll let it take the win this time. Okay, so I'm just going to rewind here, and if we jump into edit mode, first of all I'll show the AI chip, and pretty much the easiest way to see how this works is when it's in action, so I'll just change to test mode here. So you can see down the bottom here there's bars popping up in each row sequentially. Basically that bar has a bunch of trigger zones on it that scan the board for chips and rows of coloured chips. Down the right here I've got a variable for each column. They're numbered column 1 through 7, and each column is assigned a score based on how good of a move putting a chip in that column is. Now the reason it's picked the middle column is because I've added a calculator into this column's score and it adds 4 to it. What that means is it'll always have a slight score priority over the rest of the columns because it is a smarter move to make, putting it in the middle column. So the AI prioritizes the center lane again because it has the highest score with the calculator adding to it. Then I'll put my chip on the top because if it takes most of the center column it'll definitely win. So we'll just go through and fight over the center column until it's full, and you'll see that the variable and the calculator for the center column has now turned off. This is so that the score for the column will always be 0, and basically it'll always choose a lane with a score that way, so it can't choose that lane anymore. So it's picked up 80 points for the first and the third columns, and that's because there's potential to block a 3 in a row for the opponent. The AI at the moment is designed to choose the first column with the highest score. I put another chip down and you'll see from this scan the third row gets a score of 130. That's because it can block the enemy's row of 2, and it can also see that there's 2 chips already in that row for itself. So it puts the chip down there, and I'll put mine down over here just to give it the win. So you'll see for the second row it now gets a score of 400 with the potential to win the game, so it'll head over there for the win. And yeah, that's basically the AI in game, so I'll just jump into edit mode. So I'm just storing those values in variables here. And you can see each score that I've given each move. So the human player's scores are on the top and the AI scores are on the bottom. I've got these potential scores going into variables for each column, which are the ones stuck to the screen on the right over there. And it'll cycle through each column and assign the potential total for each into its own variable. At the moment I've got a fake puck dropping down each lane, and because the chip can only fall down so far, it's a quick and dirty way to see where the highest chip is and emit the chip detector at that location. Because each chip has its own score, we want to reset the potential totals in between scanning each of the columns. So I've just told to reset the potential scores each time a new fake puck drops to complete a scan. Okay, so excuse the camera work here. I'm just going to head over to the scanner chip and just open that up. So this is the little bar that pops up in each column that I showed you before. In here I've got a bunch of trigger zones for each potential way that the chips can be lined up to create a winning move. So I've got the up and down potentials, the left and right potentials, and the two diagonal potentials. If I jump into the diagonal potentials here, you can see that I've got it split up into two chips, each representing a player and looking for that player's chips. Inside these are trigger zones. These trigger zones are wired into the microchips that tell the main chip whether it's a row of 2, 3, or 4 that it's found of the same color. So if I open it up in here in the first diagonal potential, you can see that it's scanning those 4 board locations and looking for chips in that row on the board. Now the trigger zones have an awesome perk, and that's that they've got a number detected output value. What this basically does is outputs the number of chips found even if the trigger zone hasn't fully activated. So I've got all these zones looking for 4 chips, and if it detects less than that, it'll send the number counted to the other chip over here. Basically all this is doing is saying if the number of chips found is equal to 2, then it'll turn on this variable to add an amount to the P1 potential total, and that amount is defined with the score variables that I showed you earlier. That way I can update a single number on the main chip and have all of the scores updated at once and not have to go and change them all individually. Then for these other 2 chips, I've got the exact same thing going on, except it's checking for 3 in a row and the other one's checking for 4 in a row. The exact same thing is then copied for player 2, except it updates the player 2 potential score instead. Then the whole potential chip is basically duplicated exactly as it is, and the only thing that changes are the trigger zones. So I've just changed the trigger zones to be up and down and left and right in the opposite diagonal. I've got the win chip here too. Now because the trigger zone is looking for 4 chips, it'll only fully activate it and output its found signal when there's 4 chips of the same color in the trigger zone, which indicates a win. So I've wired all of these zones into the OR gate over here, and I've just said if any of these wires are active, then activate the win transmitter for that player. There's another chip that picks up the win and plays the end screen. So now I'll just show you a bit of the robot AI and how it sort of moves. On the robot that drops the coins, I've got a chip for controlling the movement. On here is a bunch of calculators that are checking what the chosen column was, which was the column with the highest score. So if it's chosen column 4 and it's currently in column 4, it'll stop and drop the coin. Now it'll choose column 4 here because the column has priority, so it moves up the columns until it finds the one it's after. Above each column I've got a trigger zone looking for the tag associated with the column, which is what makes the tags basically activate when they're detected. The things above the board also emit the fake chips for the scan. There's a bit more to it, as you can see, but that's basically how the AI works. It's very basic at the moment, but it does put up a fighting game, and it's fun to play against if you've got no one else around. Thank you guys all so much for tuning into my very first YouTube video. I hope you all have a good one. Cheers.